Good morning students. Today we will cover Kmap of 4 variable. In previous two classes we have already covered Kmap of 2 variable and 3 variable, and today we will cover Kmap of 4 variable. Now see, this is a mean term expression of 4 variables. See, you can see there are 4 variables A, B, C, D. So before starting we do the Kmap, one thing we need to make very sure that A is our MSB and D is our LSB. The MSB and LSB will be in the sequence of writing. As we are writing A, B, C, D, so A will be the MSB and D will be the LSB. Accordingly, we will do our Kmap. Now, as there are 4 variables, so how many boxes of Kmap will be there? The number of boxes will be 2 to the power number of variable. Number of boxes is 2 to the power number of variable. Small n is number of variable. So in this case, as there are 4 variables, so what will be the number of boxes? 2 to the power of 4. That is equal to 16. So 16 boxes will be there in this Kmap. Now let us do the Kmap, and one thing we will do before minimization. Why at all we do Kmap? To minimize a boolean expression. Now boolean expression, as I have told in previous classes, that boolean expression are of two types. One is in its min term or in its max term form. This is a min term form, and in its variable form. This is a min term form. So from Kmap, before minimization, we will find out the original expression in its variable form before minimization. That is the original expression. Then by using Kmap, we will minimize the expression and we will find out the minimized expression. So let us do the Kmap. See, 16 box Kmap we will have to do. So there will be 4 columns and 4 rows in the Kmap. Now we will put 2 variable in rows and another 2 variable in columns. So in this case, let us put AB in rows and CD in column. This is very important, as we are putting A in rows, so the boxes will be done accordingly. If I put A in column, then the boxes will be done in some other manner. In next class, I will show that. Now, so what will be the rows? A bar, B bar, A bar, B, A, B and A, B bar. What will be the columns? C bar, D bar, C bar, D, C, D, C, D bar. Now you can ask why this one is A bar, B bar, because, and why this one is A, B bar. So see, we will start, what will be the first row? The first row will be 0, 0, row number 0, 0, 0th row. The first row will be 0th row. So what is the binary representation of 0? 0, 0, right? Now, to represent 0, 0, what will be the variable form? There are 2 variables in rows, A and B. Now, A is the original form of the variable, that is 1. That is considered as 1. So, A bar will be 0, right? Similarly, if B equal to 1, B bar will be 0, right? So, 0, 0, that will be equivalent to A bar, B bar, right? So, this row is A bar, B bar, which will correspond to 0, 0. Now see the next row. Next row is what? This is 0th row. This is row number 1. Row number 1 means 0, 1. Right? Now 0, 1 means what? A bar, B. Okay. So this is A bar, B. Now you can ask why this is A, B bar rather than, why this is A, B rather than A, B bar. Because this should be row number 2 and that should be represented by 1, 0, but we are representing it by 1, 1. And this is, we are representing row number 3 by 1, 1. So AB. In variable form it is AB. Now why at all this is? Because according to Kmap principle, two consecutive rows or two consecutive columns cannot differ by more than one bit position. Maximum one bit position difference can be there. See, this row is A bar B. Now if this row is A B bar, then what will happen? A bar will be changed to A and B will be changed to B bar. This cannot be done. Right? Only one bit position can be changed. Right? That means, see, this is 0, 1. This is A bar B. This is A B. That means only A bar is changed. Only the variable A is changed from A bar to A. Right? Both the variables are not changed. So this is the principle of Kmap. Two consecutive rows or two consecutive columns cannot differ by more than one bit position. Right? Now if I do A B bar over there, then what will happen? If I do A B bar, this is A bar B, then A bar will be changed to A, B will be changed to B bar. This cannot be done. That is why as this row is A bar B, this row will be AB. Only in terms of A is changed, not the B. So these are the four row representations. Now column representation C bar, D bar, C bar, D, C, D, C, D bar. Just we have the first column is 0, 0, so C bar, D bar, then 0, 1, so C bar, D. Now the next one will be C, D. Because of the same principle, two consecutive columns cannot differ by more than one bit position. Then C, D bar. Okay, now what are the boxes? So if I write this in 0, 0, 0, 1 form, then this row will be 0, 0 row, this row will be 0, 1, this will be 1, 1 and this will be 1, 0. In terms of column, this is C bar, D bar. So 0, 0, this is 0, 1, this is 1, 1 and this is, what will be it? 1, 0. Right? So what will be the first box? 0, 0 from row, from column 0, 0. So 0, 0, 0, 0. This will be the first box. Now what will be the second box? See, this is 0, 0, then 0, 1. The third box will be 0, 0 from rows, from column 1, 1. This one will be 0, 0 and 1, 0. This one will be 0, 0 from, 0, 1 from rows, 0, 1, 0, 0 from columns. This one will be 0, 1, 0, 1. This one will be 0, 1, then 1, 1. And this one will be 0, 1, 1, 0. This one will be 1, 1, 0, 0. Then this is 1, 1 from row, from column 0, 1. This is 1, 1, 1, 1 and this is what? 1, 1, 1, 0. Similarly, this will be 1, 0, 0, 0, then 1, 0, 0, 1, then 1, 0, 1, 1, 1, 0, 1, 0. So if we put this number in its equivalent decimal form, then 0, 0, 0, 0 means 0. So this is box 0. 0, 0, 0, 1, 1. This will be 0, 0, 1, 1. That is 3. Binary equivalent of 3 is 0, 0, 1, 1. This is 0, 0, 1, 0. So 2. Now this will be what? 0, 1, 0, 0. So 4. This will be 5. These are all decimal equivalent of these binary numbers. This is 7 and this is 6. Right? This is, first we do this one. 1, 0, 0, 0 is 8. This is 9. This is 10. This is 11. This will be 12. 1, 1, 0, 0 means decimal equivalent of 12. So this is box number 12. 13. This is 14 and this one is 15. So these are the boxes of a 4 variable Kmap, that is 16 box Kmap. Now we will put these values. So we will put these values in these boxes. Now, as we will put these values, what we will do? We will put what are the boxes mentioned over there. We will put 1 in those boxes, and in rest of the boxes we will just put 0. Right? Is it clear? These values, what are they mentioned in this min-term expression? In those boxes we will put 1. The boxes, those are mentioned in this min-term expression, and in all other boxes we will just put 0. So, let us put accordingly. See 0, 1, 3, 0, 1, 3, 4, 5, 7, 9, 11. Now 0. So put 1. 1, 3, 4, then 5, then 7, then 9, then 11. We have put 1 in the boxes which are mentioned in the min-term expression. Right? So this is the first step of Kmap. What are the steps of Kmap minimization? First, we need to put the boxes, the values in the boxes. That means the values in min-term expression, the boxes which are mentioned in the min-term expression, in those boxes we will put 1, and in all other boxes we need to put 0. So this is our first step. Now, what is the next step? The next step is we need to do the grouping. So how to do the grouping? The rules, what are the rules of grouping? As I said in my previous videos, the rule of grouping is we need to group ones in power of 2. That means 2 ones can be in a group, 4 ones can be in a group, 8 ones can be in a group, 16 ones can be in a group. Now the another important point is the number of ones. The ones in a group must be in consecutive position. That means there should not be any box gap between 2 ones. That is, they must be in consecutive position. And rule number 3 is horizontal and vertical ones can be in a group, not diagonals. Right? So how to group this Kmap? If I group this Kmap, how to group them? See, before grouping we will group this, but before grouping we will do one important thing, that is we need to put the expression in its variable form and in its original form. The expression in its original form will be what? Before we do the grouping, we will find the expression in its original form. So function of A, B, C, D. What will be the expression? See, we need to write down expression for each individual one in the original form. That means for this one, this is what this one is, from row A bar, B bar, from column C bar, D bar. So this is A bar, B bar, C bar, D bar. Now this one, A bar, B bar, B bar, C bar, D. Now this one, this is A bar, B bar, C, D. A bar, B bar, C, D. This one, this is A bar, B and C bar, D bar. This one, this is A bar, B. This one, this is A bar, B. We have written 1, 2, 3, 4, 1, 2, 3, 4 this. So this one, this is A bar, B, C bar, D. A bar, B, C bar, D. This one, this is A bar, B, C, D. A bar, B, C, D. This one, now this one is left. This is A, B bar, C bar, D. A, B bar, C bar, D. Now this one, this is A, B bar, C, D. A, B bar, C, D. So these are this is the original expression, that is expression in its original form before minimization. We have not yet minimized. Now we will do the minimization using Kmap principle. As I have said the rules. So by using those rules of minimization, there are 3 important rules. Number of 1 should be in power of 2. There should not be any space gaps, so number of ones should be in their consecutive place. And number 3 is the number of ones in the group must be in either in horizontal or vertical orientation, not in diagonal orientation. Diagonal ones, maybe they are in consecutive place, but diagonal ones cannot be put in a group. So accordingly we will do our Kmap minimization. And while we are minimizing the expression using Kmap, one thing is very important to keep in your mind, that you need to put maximum possible number of ones in a group, right? Maximum possible by following the Kmap grouping principle, but maximum possible number of ones you must keep in a group. So see, these 4 ones, they can be in a group. They are horizontal and vertical orientation. 4 ones, that means in power of 2, 2 to the power 2 is 4, and there is not any space gap. So we will put this as a group, right? Now see, these 4 ones, they can also be in a group. They can also be in a group. Now next is this 2 ones, they can be in a group, but see, Kmap is always considered as a folded form, right? So these 2 ones and these 2 ones, they are considered as in consecutive position. What is the folded form? The folded form is what? The folded form is, suppose a Ludo board or a chess board. If we fold them, if we fold it, a Ludo board, if I fold a Ludo board, then what will happen? Suppose this is a Ludo board. Then from middle, if I fold it, then this row and this row will be in consecutive position. This column and this column will be in consecutive position. So that is the thing. Kmap is always considered as a folded form, as a folded possible form. So this row are considered in consecutive places. This column and this column, these are considered in consecutive places. So rather than taking a group of these 2 ones, what we will do? We will group these 2 ones and these 2 ones. So we will make a group of 4, because as I have already said, we will always try to make maximum possible number of ones in a group. So if it is possible to do a group of 4 ones, we will not make a group of 2 ones. We will go for a group of 4 ones. Now the next one is we will find out the expression for this group. All the, how many groups are there? 1, 2, 3. There are 3 groups. So we will find the expression for each of the 3 groups, right? What is the expression for this group? What will be the expression? While we are finding out the expression for each group, then one thing we need to, I will erase this one. I hope this is written by you, all of you. Now, while we are minimizing our expression, what we will keep in mind, that the number of ones in a group, what should be the expression for a group? The expression for a group will be the common value shared by all the elements of that group, right? Now in this group, how many elements are there in this group? 1, 2, 3, 4. 4 elements are there. So what is the common variable form shared by all these 4 elements? That will be the expression for this group. See, row wise, what is common for all these 4 elements? A bar is common. In terms of B, nothing is common, because this row is B bar, this is B. So in terms of B, nothing is common. In terms of A bar is common. So A bar. A bar. In terms of column, what is common for all these 4 ones? C bar. You can see C bar is common. So A bar, C bar. This is the expression for this first row. Now this group, what should be the expression for this group? The expression will be, see, there are 1, 2, 3, 4 ones. So what should be the expression? That is common variable form for all these 4 ones. Now what is common? See, A bar. In terms of row, from row, A bar is common. In terms of column, what is common? D, right? So A bar, D. Now see, this one, this group. How many elements are there in this group? These 2 ones and these 2 ones. Now what is common? See, in terms of row, what is common? In terms of row, this is A bar, B bar, this is A, B bar. So B bar is common. In terms of column, what is common for these 2 ones and these 2 ones? See, C bar D, C D. So D is common. So what should be the expression for this group? This group, what should be the expression? The expression for this group will be B bar and this is B bar from row and D from columns. So B bar D. So what is the minimized? No single one is left. So all the ones we have put in groups. So our grouping is over. And we have also found out the expression for each individual groups. Now what we will put? We will put all these group expression in a single expression of SOP form. Why SOP form? Because our original form was in min term form. So min term form will always give you in SOP expression. So what is the expression? Function of A, B, C, D. What is the expression? The expression is A bar C bar plus A bar D plus B bar D. This is the minimized expression. So this is for today's class, and in the next class we will move to don't care condition using Kmap. Okay, so thank you, and if you have not subscribed the channel still, please subscribe the channel so that you will get the contents of the channel. Thank you so much.